Hello everyone, my name is Devinder Kaur and you all are welcome to my YouTube channel, The Enlightened Room. In this video, we will study about work and energy. So let's get started. In layman language, work is said to be done if you are doing any kind of physical work or mental work. Like you are doing your homework, you are doing some mental work, it is considered to be as work. You are calculating something, you are solving the numericals, you are solving the questions or sums, or you can say the problems of mathematics. You are doing some, you are studying some economics, you are reading a book. It is said to be work in layman language. Similarly, for physical work, you are carrying some weight, you are moving a trolley, you are rolling a stone, you are trying to roll a stone, you are playing with football. Okay, so in layman language we can say that the work is said to be done, but in the physics world or in the scientific world, all the examples are not considered in work. Well, what kind of examples you can take in physics world of work? So what kind of examples you can take in physics so that you can say yes, the work is said to be done? So let's take a look at it. When a box is pushed on a floor by applying a force, it moves through some distance. Work is said to be done. In this case, applied force displaces the box. When we pull a trolley by applying a force and it moves through some distance, work is again said to be done. When we lift a box through a height, we have to apply force. In this case, the applied force does work in lifting the box. So from above all the examples, it follows that work is done if a force is applied on the object and the object displaced from its original position. No work is said to be done if any one of the two conditions is not satisfied. So from these examples, we can mathematically define work as W is equals to F times S. Well, W here is work done by an object by applying a force on that object, on another object, okay, and after applying the force, the object moves some distance, or we can say in the mathematical form, some displacement. Now what is displacement? We will first study about the displacement. Let us suppose you are standing here on the position A, okay, and your friend is standing here on the position B. So you have various ways to reach your friend. You can either reach here like this by following this path. You can follow this path. You can follow this path too, or you can follow this path. So we can say that we have 4 paths to reach your friend who is standing at the position B. So in this one is not the shortest path. You had to move some more distance. Well, these all are kind of distance. In all these 4 cases, you have moved some distance. Okay. So distance is what kind of path you have followed, not the what kind of path you have followed. It is just path you have followed. You have moved. So that is distance. But displacement is the shortest distance you have traveled. So let us say this is the initial position. This is the initial position. And this one is the final position. Okay. So it can be said that displacement is the shortest distance traveled between the initial position and final position of an object. So this is displacement. So that means you have this box here, okay, on the table, and you have applied some force from this side and it moved some displacement, it covered some distance. That means it tried to had some shortest kind of path, some shortest path, and it moved some distance, or you can say this displacement for the mathematical point of view. It moved some distance or displacement, and then from this whole condition we can say work is said to be done. Now you all know that force is measured in Newton. The SI unit of force is Newton. Similarly, the SI unit of displacement is meter. Well, displacement is also shortest distance travelled. If distance is measured in meters, then displacement is also measured in meters. Also, displacement is a vector quantity. Okay, it has some direction now. So, it is a vector quantity. Force, in which direction it is applied, that means the direction is given. If for any quantity the direction is given, it is considered to be as vector quantity. So, force is also a vector quantity. So, work would also be a vector quantity. In which direction the work is said to be done, right? Similarly, if force is measured in Newton, displacement is measured in meter, we can say the SI unit of work is Newton meter, or we have some simpler form, simpler value. The SI unit of work is joule or joule, which is represented as capital J. Okay, so this is all about the mathematical point of view of work. Well, the direction of displacement of an object and the direction of force can have different relations with each other. The directions of force and displacement may be same, opposite, perpendicular to each other, or there may not be a displacement at all. So, let us find the work done by the force in each of these cases. Now, in this case, force is acting in the direction of displacement. You can see this block here or this object here placed at this certain point and acted upon by a constant force. Now the block is displaced, or that object is displaced through a distance s to a new position. So work done by the force is equal to the product of force and displacement, which is given here. Now let us take another example. Force is acting in direction opposite to the displacement. So in this case, force is acting opposite to the displacement of the body in motion. So work done is negative. Well, this happens when object is moving in one direction while the force is acting in the opposite direction. That is, force is retarding the motion. A typical example is that the work done by the frictional force, which usually acts in the direction opposite to that of displacement, is considered as negative. Further, if an object is thrown up, its displacement is in the upward direction, whereas the force acting on it due to Earth's gravity is in the downward direction. The work done by the gravity on an object thrown upwards is negative. The third one is force is acting perpendicular to the displacement. In this case, the force F applied is perpendicular to the displacement as shown in this figure. Obviously, there is no displacement in the direction or parallel to the force. Work in this case is considered to be 0. The fourth one is force is causing no displacement. So in this case, S is also 0, such that work done is said to be 0. Well, this happens when one may holding a heavy object. In this case, there is simply a force but no displacement. Further, no work is done when one may be pushing a rock and is unable to move it. Thus, we conclude that work done by a force is positive when the force is acting in the same direction as the displacement. Work done by a force is negative when the force is acting opposite to the direction of displacement. Work done by a force is 0 if there is no displacement in the direction of force or the force is acting perpendicular to the displacement. So work done by a force acting on an object is equal to the product of the force and the displacement of the object in the direction of force. Now let us consider the whole term mathematically. Well, work is said to be done if some force is applied on an object and it moves through some distance. So let us consider this case that the force is applied on an object in a particular direction and the object has moved in that same direction. So let us try to find out the angle between them. So I am taking the case of same one. When the direction of force and the direction of motion of an object is same. So from here the direction of force is here like this and the direction of motion of the object is just the same. So where is the angle formed? Well, angle formed is like this kind of view, that the angle has been formed when the two rays this kind of meet. So from here there is no angle in between them. So we can say the angle here is 0 degrees. Now what is this this thing? This is known as theta, okay, and this is the denotation of an angle. So from the mathematical point of view of work, it is F times displacement. Well, in physics, when we remove the sign of multiplication, well, there are two kinds of multiplication in physics. One is dot product and the other one is cross product. So in one of them, when we remove that sign of multiplication, we use the value cosine theta. Okay, now the theta here is 0. So we will put the value f as cosine 0. Now for your knowledge, cosine 0 degree is always 1. So it is f times s, simply f times s. So we have got the positive value. Okay. Now if the direction of motion of the object and the direction of force applied is opposite, that means, okay, we can say it here that the object is moving in the certain direction and some frictional force is applied on the object which is opposing its motion. Okay, so for that you can say this kind of figure has been formed, and the angle between them is, since this is a point of the meet, so angle between them is considered to be as 180 degrees. So since it is 180 degrees, so W equals F as, I'm going to just simply write it as cosine 180 degrees, and the value of cosine 180 degrees is -1. So it is F times S -1. So we will get W equals negative of Fs, which we had done in the theory. So now we have proved it mathematically. Okay. Now if the direction of force applied and the motion of the object, the direction of motion of the object is perpendicular to each other. Now for that we can say an object is moving in a certain direction S, and the force of gravitation is acting on that object. So for this we can say the angle formed is 90 degree, and these two directions are normal to each other, or you can say perpendicular to each other. So for that W equals F as cosine of 90 degrees, and for your knowledge, cosine of 90 degrees is always 0. So the whole term is 0 because it is in the multiplication. It is in the simple multiplication now, as we have removed the product, some certain kind of dot product or cross product. So it is in simple multiplication, and in simple multiplication F times S times 0 would come out to be 0. So the work done here is 0. Now if there is no displacement at all, then if the displacement is 0 for the fourth one, okay, sorry, for the fourth one, the fourth option we had discussed, if the displacement is 0, then force is also 0. In the multiplication, the force would be considered 0 and the work done is also 0. Okay, so today we have completed our topic work. In the next video we will discuss about the energy. So if you found my video useful, like it, comment it and share it with your friends. And also if you are new to my channel, subscribe to my channel. Thank you so much.